Here's page 3, and the square root radical here is isolated, so we can go right ahead and square both sides. I'm going to get a little lazy now and just do this. Save some space too. So squaring that square root removes that square root radical sign. On the other side, remember you're doing x plus 2 times x plus 2. If you need to write it out, go right ahead. That's translated to x plus 2 times x plus 2, which would make an x squared plus a 2x and another 2x for a 4x in the middle, and then plus 4 at the end. Right now this looks quadratic, but as soon as we subtract 1x squared from both sides of it, we're left with this little linear equation. 3x plus 8 equals 4x plus 4. And now it's pretty simple to finish up. Take away 3x from both sides. And it says 8 equals 1x plus 4. Take away 4 from both sides, and we'll have 4 equals x. And if you try the 4 in there, it does work. It comes out 6 on, but you get square root of 36 equals 6, so it's fine. Now here's an example where the radical is not isolated yet. If you square both sides right now, it's going to make a terrible mess, and you probably won't get an answer either. I'll add 2 to both sides. If I add 2 to both sides, that'll get that square root isolated. Of course, copying it carefully is important too. So, square the left side, like so. Square the right side, like so. On the left side, we just did this a moment ago in problem 9. X plus 2 times x plus 2 is x squared plus 4x plus 4. On the right side, we have 7x plus 4. And if I subtract 7x and subtract 4 from both sides, that'll leave a 0 over here, and we'll have all the other terms on this side, and it's going to be a quadratic that we will attempt to factor. I'll take away 7x, take away 7x, take away 4, take away 4, and then we have x squared minus 3x, 0, so nothing else to write there, equals 0. And this is kind of nice. All we do here is factor out an x, and we have x times x minus 3 equals 0. So this quadratic has 2 solutions. X equals, if this times this equals 0, either x equals 0 or x equals 3. Now, do they both work, or does either one of them work in our original equation? Well, let's see. If we plug in the 0, plugging in 0, it would say 0 equals square root of 7 times 0 plus 4, subtract 2. True or false? It's true, because this is 0 plus 4 is 4. Square root of 4 is 2. 2 take away 2 would be 0. So that checks out. And if we try the 3, that also works. Plug in the 3, and it's going to look like this. There's a little question mark for the moment. This is 21. 21 plus 4 is 25. Square root of 25 is 5. 5 take away 2 is 3. So both solutions perform as they should. Okay, number 11. A little bit of a step up here. Need to isolate the radical first, as always. So I'm going to take away 3x from both sides. And then this is going to say 3 times the radical equals 39 minus 3x. Now we haven't had this before. This is multiplying the radical. Can we divide everything by 3? Yeah, these are all divisible by 3. So let's divide both sides of the equation by 3. And then we'll have just plain old square root 5x plus 1 equals 13 minus x. At this point, we're ready to square both sides. On the left side, we just get rid of the square root symbol. On the right side, what's going on here? It's 13 minus x times 13 minus x. So we get 169 minus 13x again makes it minus 26x in the middle, and then minus x times minus x, that's plus x squared. So we've got a quadratic. It's going to stay quadratic. The x squared is not going to disappear like in some of the other examples. So we want to get this stuff out of here and leave a 0 just so that we can attempt to factor the right-hand side. I'm going to take away 5x from both sides. I'm going to take away 1 from both sides. Now I have 0 equals 168 minus 31x plus x squared. And this makes me nervous looking at it backwards like this, so I'm going to rewrite it the ordinary way, x squared minus 31x plus 168. I feel much better. It's a 1x squared, so we need two numbers that add up to negative 31 and at the same time multiply out to 168. Okay? And they're not that easy to find. I mean, you could do the AC method trick with the calculator, but if you do 168 divided by 7, you get 24. So 7 and 24 add up to 31. If we make it negative 7 and negative 4, they add up to negative 31 and they multiply out to 168. Anyhow, there's how we could factor that. So this quadratic says try 7 or 24. If we try the 7, let's go back up. 7 and 24 are our candidates for solution. If we try the 7, it's going to say 3 times the square root of 5 times 7 is 35. Plus 3 times 7 would be 21. Is this true? See, well, that's 35 and 1 is 36. Square root of 36 would be 6. 3 times 6 would be 18. So all that smashes down to 18. 18 plus 21, 39. So 7 works. If we try the 24, let's try the 24. I'm going to run out of room here. 3 times 5 times 24 is 120. And 3 times 24 is 72. You see right now that this does not work because this is going to be 11. 3 times 11 plus 72, that's up over 100. No way that's coming out to 39. So the 24 is not a good solution. The only solution we have is the 7. That's the end of page 3.